Hello everyone, my name is Krishna and today we are discuss about time and space complexity. So here we are discuss what is time complexity. First we are discuss what is time complexity. Here we are written a problem. So time complexity is it is the total time taken by an algorithm to run as a function of length of the input. uh, it shows how much time are to be taken by a problem. Your problem is how much time are we taken. Our problem are not take in 1 second, not 2 second, not three. Our problem are take actually 10 to the power 10 time 10 to the power 90. It shows in 9 millions, billions, trillions. Got it? All right. So here we are. I'm written here. One here is a this is a problem. After that, I have to write two solutions of that problem. First solution I take 5 second, and second I take 10 second. But the less time to be take, the problem is to be take less time. That is to be a best time complexity. All right. So I'm also written here. Those solution take less time. That is to be satisfied by the time complexity. Okay. Next we have these two graphs. I'm written here. These are two graphs. These all are these both are linear. These the behavior of the graph are to be linear. Here we are seeing this graph is to be 10 to 10, 20 to 20, 30 to 30. So it shows the behavior of the graph are n time. It's go to the n time, 10, 20, 30, 40. But in this graph we are seeing 10 to below 10, 20 is middle of 10, 20 point is to be there, 30 is 20 middle 30, so that is to be decreases, that is to be half of the number. So my good time is to be this graph is to be n by 2 time, work on a n by 2 time. Got it? Let's see what happened after the videos uh, in the on the questions actually. Next we have, what is this? This is actually a representation of complexity. It shows big O. It shows big O. Big O is just like a representation of complexity. Big O notation. In the bracket we are written here time taken by a code. Got it? So let's see what happened. This is time complexity. This is actually a graph. This is a very complex graph, I know, but we all understand it. Okay. First, this is the graph. This is input and number of operations. Y-axis are to be shown number of operations and x-axis is to be input size. My constant graph is shown to be big O of 1. In the circular graph, it's big O of log n, and the graph is to be increases. So the here I am written if the graph are increases, then it is to be a worst case complexity, and the decreases and the constant graph is to shown as best case complexity. Big O of 1 is actually a best case complexity. Got it? These are graphs. Big O of 1 constant, big O of n, it's a linear graph. Big O of log n, circular graph. Big O of n square is bottom circular graph. Okay, it's bottom to upper side, it's bottom to right side. That's a theory of these graphs. Right, big O of n square is it's next we have terminologies. What is terminologies? in this topic, terminology like there are three terminologies. It shows it is a part of time complexity. It is a part of complexity. Like big O, I'm written here there, omega, theta. These are the three terminologies. Okay, big O, just like worst case complexity, omega is best case, and theta is to be average case. But mostly used case are to be big O of notation, worst case complexity, big O of n, big O of n square. Omega theta is okay, but big O is to be very most important complexity. We have to understand it. Okay, next we have some examples. Without example, we can't understand what problem says, what the complexity, what happens are here. Okay, next first example are listen. For int I is equal to 1, I less than equal to n, and I plus plus. The program says my program is to be working on 1 to n time. Got it? 1 to n time. And my program is running on 4 time. First are 4 time. 1, 2, 1, 2, 3, and 4. So I have written 4 here. Next are not 4 time because 1 time already done. 2, 3, and 4. Sorry, 1, 2, 3. So 3 time. 3 time. After that 3, 3, 3, 3, 3 time. And it's run on 3 time only. After that we have to do a sum. So how can it is possible? Because 4 are there, so we can't sum these progression. So we have to do 4 is equal to 1 plus 3. Can we return? Okay. So 1 is 1 plus 3 plus 3, 3, 3. 3 is equal 3. Sum is that n time it's running. So 3n plus 1. This one is written to be here. So my first rule says that if the value are constant, if any constant value, if any number are there, that is to be ignored by the solver. Okay, and the complexity 3 is to be constant, 1 is to be constant, so my n is to be vacant. Then I have written the complexity is big O of n. This is actually a worst case complexity. Rule 1 is ignore constant term, right? I'm request everyone, please follow my channel, please subscribe my channel, and like, comment everything. Please do it. Okay, because subscriber is very important. Without subscriber I can't manage. Okay, please, I'm requesting you everyone. My next rule is this. This is actually a example. With the help of example, I have to know 2n is n cube plus 3n square plus n. 3 and 2 is constant, 3 is constant, so I have written here n cube n square n. But second rule says uh, if the power is bigger than another power, if the bigger power is there, that is to be my complexity. N cube n square n. What is the bigger than n square? N cube. What is the bigger than of n square? N. And n square is less than n cube. So the complexity is n cube. N square and n is small one. So that is to be removed it by the solve. रूल सेट की जो छोटे हैं उनको हटा दो. That is my complexity. Okay. Right. Next we have for this example, for I equal to 0, I less than n, I plus plus, and this. So what can I do here? This is actually a good one. My program is done in n time. Okay, this is an example. One time, so my complexity is actually n, because 0 to n time is running. Because this is not to be in the complexity. This thing is to be came in complexity, right? This is an example. Big O of 0 is there because we have to find the index element. Index, this 0 index. It take more step. That why is the worst case? It's a worst case. That is only a reason, because it's working off n time 0 1 2 3 4 5 like that. Okay. Next we have example is n into n plus 1 divided by 2. If I am right, if I give any value 100, 1000, so I have written 100 here, and all the value is to be constant. I have calculated it, so all the value is constant, so my complexity is big O of 1, right? After that, I have next example. Here we are seeing two loop. This is to be work on this time. This loop are running to be 1 to n time. This is also running on 1 to n time. So so the complexity is first n, second is also n. So and we have to into multiply both the complexity. It shows big O of n square, because we have two loop in the program. Okay, the rule is that first third one rule are is, if I j is equal to I and j is less than equal to also I. Okay, if I is not there in j, so we have to write big O of n. If I is there, so we have to calculate it, right? So we have just this is actually 1 to n time is running, 1 to n time is running, 1 to n 3 n time is running, and n time is running, so n square, because two loop are there. Okay, after that we have two for loop. Okay, but I is in there, I is there in second for loop, j in case of j. So I have just calculated I is running on one time, so j is to 1 to 1 time, because I is there 1 to 1 time, 1 to n time 2 in second case. In third case is 1 to 3 time, 1 to 3 time. So the complexity is no. Here is one case. We have to sum of these question. It's running on 1 to n time, n time it's running. And the formula of the progression of the summation of this progression, n into n plus 1 divided by 2, and we have to calculate it. The complexity is to be n square, right? After that we have one more or example are there. Two for loop I have written here. Okay, 1 to n time it's running. For j for loop is 1 to I square. 1 to 1 1 plus 1 to 1 square is 1. 1 to 1 2 square is 4. 3 square is 9, and 1 to n square. So it's running on 1 time, it's running on 4 time, it's running on 9 time, it's running on n square time, right? If I did a summation of this number of this progression, n into square progression, n plus 1 to n plus 1 divided by 6, this is constant. If we are multiply all of them, so my complexity is n square. N square also are there, but n square is less than n cube, so my complexity is n cube. Got it? Okay, so my next example is we have for loop here. It's running on n time, it's running on m time, so my complexity is n into m. Got it? Because here not any I in the for loop of j, second inner for loop. Got it? Right? And after that we have one more example. For I is equal to 1, I less than n, I plus plus. Second for loop is running on I square time, and third are n by 2. So it's a problem because I square are there in inner loop. So we have to calculate it. It's running on 1 time, it's running on 1 to 1 time, because 1 square is 1 and 2 time. This here is 4, here is 9, because 3 square 9. So my program is running on n by 2 time, 4 n by 2 time, 9 n by 2 time. If we are doing data summation, so we have to take a common. After that we have to write a formula and all of them. So my complexity is to be n square. right? Not n square, sorry, my complexity is n की power 4 because we have to summation of the, we have to multiply all of them, so my complexity is to be n की power 4. Got it? This is my complexity, right? After that, one more example, I I less than n, I into 2, and the C out are there. I into 2 it's running on one time, I one time, two time, three time, four time, eight time law. Sorry, eight time because into two are there. One into two, two, two into two, four, four into two, eight, and the and it's running on one time, one time, one time, one time actually. Okay, because constant are there, not I square and okay. So if 2 की power 0 is 1, 2 की power 1 is 1, 2, 2 की power 2 is 4, 2 की power 3 is 8. So, and it's running on n into 2 की power k, because this power I have written here k time it's running, n is equal to 2k, and we have to take log both side, and k is equal to written here log n by log 2 because k is there, log 2 is coming bottom side, and after that its k value is log 2n, so my complexity is log 2n, right? Because 1 hour is to be constant. Got it, everyone? So this is all about time complexity, and this is direct to be these are direction of time saving techniques. If 1 2 4 two difference are there, so log 2n, 3 का difference is there, so log 3n, 4 का difference आता है तो log 4n,